All right, this next one is asking us to find the missing parts of triangle ABC. C is 37.2, A is 105 feet, and C is 215. So again, when I draw that, A, B, C, and label what I know. C, 37.2 degrees. Little a, 105 feet. And little c, 215 feet. You can see side-side angle where the angle is not between the two sides. So this could be one triangle, two triangles, or no triangle at all. The angle they give me is C of 37.2. That is acute. So immediately I'm thinking, okay, this might be two triangles. Let's find out. The ambiguous case could occur. All right, here we go. Let's go for our first triangle and see if it gets us anything. So law of sines, we have the sine of 37.2 degrees over 215 feet will equal, and since 105 is across from this angle A, it would be the sine of A, we will call it A1 for now, over 105. All right, immediately we see we're going to multiply by 105. Because when I multiply by 105 on both sides, it looks like that. And then we are going to take the sine inverse. And when we take the sine inverse, I have to make sure I am in degree mode because this is in degree mode and I want my answer in degree mode. All right, so let's grab the calculator and type it in. Sine inverse 105 times sine of 37.2, notice in that decimal place, in parentheses for sine, in parentheses for the numerator, divided by 215, in parentheses for sine inverse. Okay, I get 17, and I'm going to keep a 0.2 this time. So my A1 is 17.2 degrees. Is that my only angle? Is this my only triangle? Maybe. Let's do a little bit of work. So here we have that our angle C is 37.2 degrees. Our angle A1 is 17.2. So when I go to find my angle B, we'll call it 1, we're going to do a little subtraction, figure out what that is. These are very small angles, so I know this one works. 180 minus 37.2 minus 17.2. Wow, angle B is going to be 125.6 degrees. Okay, that is my A1, B1, and then of course angle C is true for both. It's this angle we found first that I'm going to have to do a little bit of work on. Maybe that's my only answer. Maybe not. Okay, I'm going to take that A1 and try to figure out the other angle. So if A1 is 17.2, then I take 180 minus that A1. And that gives me 162.8 degrees. All right, so my possible A2 is 162.8 degrees. Well, let's put it to the test. I know for a fact that my C has to be 37.2. So to find my B2, I got to do a little subtraction. Okay, so I take that 180, I subtract off the 37.2 that's already in there, and I subtract off the 162.8, and I get womp womp. Oh, that's a negative 20. Negative 20 degrees, that is illegal. You can't have an angle that is negative when you're inside of a triangle. So it looks like this triangle is only one triangle. When I tried to do the second triangle, it was the ambiguous case. So this has only one triangle. It did ask me to find the missing parts. So let's see what I know and don't know. Now that I know, I only have one triangle that fits. All right. So my A1, which is the only one, is 17.2. My B1 is 125.6. So I have all the angles. We also know that side C is 125. No, it's not. It's 215 feet. I also know my angle A was across from side A, 105 feet. So it looks like I don't know little b. That's the side I'm missing. Well, I'll just come over here and do the same thing I did up here. Sine of 37.2 degrees over 215 will equal the sine of, I know what my angle B is, it's 125.6 over side B, which is unknown. All right, again, we multiply B times the sine of 37.2 degrees, 215 times the sine of 125.6 degrees. And then B is multiplying here, so we will divide by sine of 37.2 degrees. Okay, now it's time. I will type all this in my calculator. I am in degree mode because I am using sine of 125 and 37.2 degrees. So here we go. 215 times the sine of 125.6. Now make sure to end that parentheses. All that's being divided by the sine of 37.2. Whoa! But you know, that makes sense because angle B was a obtuse angle, so that should be a really big side, and it is 289.1 or just 289, I guess. If you look at the other feet, they're all whole numbers. Pay attention to what it says for you to round to.